Hello everyone! Our lesson for today is about greatest common factor. Are you ready? Good. Then let's get started. When you say greatest common factor or GCF of two or more numbers, it means the largest number that is a factor of each number. Or in other words, it is the largest factor that is common to both numbers. To get the GCF of two or more numbers, we will use continuous division method. But take note that there are other methods which can be used like prime factorization or listing method. But in this lesson, we will only use continuous division method. Now let's proceed to our examples. Let's try to find the greatest common factor of 24 and 36. Again, to find the greatest common factor of two or more numbers, we will use the continuous division method. We will start by writing an upside-down division bar which looks like this one. Then let's put 24 and 36 inside. Now, we will look for a number that can divide both 24 and 36. Again, take note that it should be a number that can divide both the numbers inside our upside-down division bar. Since 24 and 36 are both even numbers, we can start with 2. 24 divided by 2 is 12 and 36 divided by 2 is 18. We will continue dividing until we get numbers that are relatively prime. When you say relatively prime, it means that the numbers have no other common factors aside from 1. So let's continue dividing. 12 and 18 are even numbers, so we'll divide them again by 2. 12 divided by 2 is 6 and 18 divided by 2 is 9. This time, 6 and 9 are both divisible by 3. 6 divided by 3 is 2 and 9 divided by 3 is 3. Now, 2 and 3 are relatively prime, so we'll stop dividing here. Then, what we'll do next is to multiply all the factors on the side. So we will have 2 times 2 times 3, and that will give us 12. Therefore, the GCF of 24 and 36 is 12. Now let's try some more examples. What is the GCF of 18, 24, and 36? Again, for us to find the GCF of these numbers, we will use continuous division method. We will have 18, 24, and 36. Since all these numbers are even numbers, we can start again by dividing them by 2. 18 divided by 2 is 9, and 24 divided by 2 is 12. 36 divided by 2 is 18. 9, 12, and 18 are all divisible by 3. Let's continue. 9 divided by 3 is 3, 12 divided by 3 is 4, and 18 divided by 3 is 6. Now 3, 4, and 6 are relatively prime, therefore we will stop dividing here, and we will multiply 2 and 3. So we'll have 2 times 3 is equal to 6. That means the GCF of 18, 24, and 36 is 6. Let's have the third example. Find the greatest common factor of 24, 64, and 108. Again, for us to do that, we will use continuous division method. So we'll have 24, 64, and 108. All these numbers are even numbers, so we can start with 2. 24 divided by 2 is 12, 64 divided by 2 is 32, and 108 divided by 2 is 54. Again, all our numbers are even numbers, so we'll divide them again by 2. 12 divided by 2 is 6, 32 divided by 2 is 16, and 54 divided by 2 is 27. This time, 6, 16, and 27 are relatively prime. There's no other number which can divide all of them aside from 1. That means we will stop dividing here, and we will now multiply these factors. And 2 times 2 is equal to 4. So the GCF of 24, 64, and 108 is 4. Now let's have a word problem. Carla has 21 red clips and 18 yellow clips. She wants to use all the clips to create identical sets of clips for her friends. What is the greatest number of sets she can make? Let us take note that she wants to create identical sets. That means the first thing we need to do is to divide the red clips in such a way that all red clips are divided into the same number with no excess. Since there are 21 red clips, we can divide them either by groups of 3 or by groups of 7. Then we'll also divide the yellow clips in such a way that all yellow clips are divided into the same number with no excess. Since there are 18 yellow clips, we can either divide them by groups of 2, groups of 3, groups of 6, groups of 9, and so on. But since we are asked to find the greatest number of identical sets she can make, that means we will need to get the GCF of 21 and 18. And to do that, we will use the continuous division method. 21 and 18 are both divisible by 3. 21 divided by 3 is 7, and 18 divided by 3 is 6. Now, since 7 and 6 are relatively prime, this means that 3 is already our GCF. Therefore, she can make 3 identical sets of clips for her friends. And this is how it looks like. So in each set, there will be 7 red clips and 6 yellow clips. Now let's proceed to our last example for today's lesson. Let us read together. A fruit vendor has 56 apples, 64 oranges, and 72 bananas. If he wants to put them together into baskets, what is the greatest number of identical baskets he can make with no fruit left over? So this question is almost the same as the question we had earlier. But this time, we are asked to look for the greatest number of identical baskets. Okay, so let's solve. Again, for us to find the greatest number of identical baskets the vendor can make, we will use the concept of GCF. So let's find the GCF of 56, 64, and 72. All these numbers are even numbers, so we can start with 2. 56 divided by 2, that is 28. 64 divided by 2 is 32, and 72 divided by 2 is 36. Again, our numbers are even numbers, so we'll divide them again by 2. 28 divided by 2 is 14, 32 divided by 2 is 16, and 36 divided by 2 is 18. The numbers we have are again even numbers, so let's divide them again by 2. 14 divided by 2 is 7, 16 divided by 2 is 8, and 18 divided by 2 is 9. This time, 7, 8, and 9 are relatively prime, so we'll stop our division here. And we will multiply these numbers. That will give us 2 times 2 times 2, which is equal to 8. Therefore, the GCF of 56, 64, and 72 is 8. That means the vendor can make 8 identical baskets of fruits with no leftover. And this is how it looks like. Wow! We're done with our lesson for today. Good job, everyone!